We are increasingly managed by systems that predict our actions and shape our environments with surgical precision. Yet these systems achieve this degree of control without possessing a shred of what we would call genuine understanding. This creates a problem for classical philosophy. Edmund Husserl argued that human consciousness is intentional. It is always directed toward a lived world. To perceive is to assign a specific meaning to the things around us. Historically, the humanities have assumed that this shared semantic understanding is the prerequisite for any social interaction. To govern or be governed, we believed two parties had to share a common world of historical and cultural meaning. This was the core of Hubert Dreyfus's critique of early AI. He argued that machines would inevitably fail at human tasks because they lack the unconscious background of common-sense knowledge that gives symbols their meaning. Following Heidegger's concept of the ready-to-hand, Dreyfus suggested that human expertise is not a process of searching through possibilities, but an intuitive grasp of context. We don't just know that, we know how. For decades, this critique served as a defense for human exceptionalism. If a machine couldn't understand the nuances of the social world, philosophers argued it could never truly navigate or manage human society. But this humanistic requirement, that governance depends on comprehension, is being circumvented by the functional reality of modern machine learning. Sub-symbolic AI manages human behavior by bypassing intentionality. It does not need to know what your actions mean to determine what your next action will be. This marks a shift from classical hermeneutics, which asks why an action happens to find its meaning, to algorithmic prediction, which focuses strictly on calculating what comes next. These systems do not rely on explicit rules or language. Instead, they function through the aggregation of massive probabilistic models, identifying correlations within behavioral data that are invisible to the human observer. Our interactions are translated into correlational recursivity. The system identifies a pattern, feeds it back into the model, and refines its prediction without ever needing to grasp the causal why behind the data. While humans rely on empathy and shared experience to navigate social life, the machine relies on syntactic grammar. It treats the human subject as a sequence of variables to be processed mathematically. By focusing on statistical regularities rather than semantic understanding, the system gains the ability to steer behavior through the management of probability. Bruno Latour's actor network theory provides the framework for this shift. It suggests that society isn't just a collection of humans, but a network where technologies and people are inextricably linked. Latour introduces the principle of symmetry, where humans and non-human technologies are treated as actants within a flat network. Each actor is defined by its relations to others, regardless of whether it is biological or silicon. The machine does not need to enter our subjective world because we have already standardized our social reality to be machine legible. We translate our hand-washing into machine cycles and our speech into digital text, inscribing our actions into the network's technical requirements. This leads to vectorization. The nuances of human environments are reduced to an n-dimensional latent space. Every action is mapped as a coordinate, turning lived experience into a series of mathematical points. In this vector space, emotional states and personal histories are stripped of their symbolic depth. They are redefined by their mathematical distance and proximity to other data points. Because the system operates on these geometric relations, the need for structural empathy is removed. The algorithm doesn't need to feel your distress to predict how that distress will affect your click-through rate. Social reality is now so tightly woven into the technical that human intentionality is no longer the primary driver of the network's function. Norbert Huckler calls this concept sub-symbolic selectivity. It is a form of structural power that operates far below the threshold of our conscious awareness or language. This chart details the clusters of AI selectivity, showing how sub-symbolic AI pre-structures our options through technical limitations. Row 3 defines objectification. AI explicates knowledge into data, forcing a reduction in complexity. Furthermore, row 7 identifies stochastics. Its probability-based functioning creates distorting selection processes favoring certain behaviors. These stochastics rely on the actome, the pre-reflexive micro-behaviors like scroll speeds and hesitations. These are the fundamental units of behavioral data. Algorithms capture these actomes in what is called the missing half-second. This is the window of time before conscious reflection can occur, allowing the system to harvest our impulses before we've even decided to act. By capturing data before a thought is fully formed, the AI manages our pre-conscious behavioral traces, rather than our deliberate, conscious choices. This architecture creates a psychological shift. The platform begins to act as an exogenous prosthetic ego, performing the cognitive work the human subject cannot. Human rationality is bounded. We are limited by our biological drives and an innate difficulty in processing vast streams of conflicting information or calculating complex probabilities. We also live with Knightian uncertainty, the simple fact that as humans, we do not know the future. Platforms bridge this gap using sequential Bayesian updating. This is the mathematical engine that continuously updates its models of our behavior. The machine treats every micro-interaction as evidence. It updates its posterior distribution, which instantly becomes the new prior for the next micro-interaction. The algorithm executes the optimizing math that the human mind is biologically unequipped to perform, constantly refining its prediction of what you will do next. By managing these predictive models, the machine anticipates the subject's desires. It effectively intervenes before the conscious I has the chance to formulate a decision. In Lacanian theory, human subjectivity is centered on the question, que vois? What do you want from me? Historically, identity is formed in the gap of uncertainty that follows that question. This period, the time for understanding, allows the subject to reflect and formulate an autonomous response. The algorithmic architecture bypasses this psychological process. By looping the user's past data traces back to them as predictive prompts, the system pre-calculates what Lacan called the future anterior. The time for understanding is replaced by the hyper-immediate temporality of the click. The algorithm preemptively answers the question of desire. It fills the gap of uncertainty with a recommendation, preventing the subject from ever needing to articulate their own want. This establishes a regime of grammarality without meaning. Our biological drives are optimized into informational rent through the execution of mathematical grammar. The power of AI does not reside in its ability to understand us. Its power is found in its ability to reduce the human subject to a vectorized interval in an exhaustible combinatory of notations.